In 1913, Henry Moseley showed that the atomic number of an element is a more fundamental property than its atomic mass. Accordingly, Mendeleev's periodic law was modified and atomic number was adopted as the basis of modern periodic table. And the modern periodic law can be stated as properties of elements are a periodic function of their atomic number. The modern periodic table has 18 vertical columns known as groups and 7 horizontal rows known as periods. Elements present in the same period have the same number of shells, which is equal to the period number. On moving from left to right in a given period, the number of electrons in the valence shell increases from 1 to 8, while the number of shells remains the same. The first period contains only 2 elements, which is hydrogen and helium, and is known as the shortest period. The second period, which is from lithium to neon, and the third period, that is from sodium to argon, contains 8 elements each and are known as short periods. The fourth period, which is from potassium to krypton, and the fifth period, rubidium to xenon, contains 18 elements each and are called the long periods. The sixth period contains 32 elements and is also known as the longest period. The seventh period was considered as an incomplete period before. However, after the recent discoveries of the new elements and their addition to the periodic table, the seventh period is officially complete. The modern periodic table contains 18 vertical columns, like I said before, known as groups. Group 1 elements are known as alkali metals. Group 2 elements are known as alkaline earth metals. Group 15 elements are called as nitrogens, whereas group 16 elements are known as chalcogens. And group 17 elements are known as halogens, and group 18 elements are known as noble gases. You will find that the elements present in any one group have the same number of valence electrons. For example, elements such as fluorine, chlorine belong to group 17 and have 7 electrons in their valence shell. The maximum number of electrons that can be filled in a shell can be calculated by the formula 2n squared, where n is the number of the given shell from the nucleus. Now let's find out that for K shell, it's going to be 2 into 1 squared, which is equal to 2. So the first period has 2 elements. For L shell, it will be 2 into 2 squared, which is equal to 8. So the second period has got 8 elements. For M shell, it will be 2 into 3 squared, which is equal to 18. As outermost shell can have only 8 electrons, so the third period also has 8 elements. Metals like sodium and magnesium occupy the left hand side, whereas non-metals like sulfur and chlorine occupy the right hand side of the periodic table. Silicon and some other metals exhibiting properties of both metals and non-metals are termed as semi-metals or metalloids and are positioned in the middle of the periodic table. There is an anomaly when it comes to the position of hydrogen because it can be placed either in group 1 or group 17 in the first period. Now this is because hydrogen resembles both alkali metals and halogens. It can lose one electron like alkali metals and also gain one electron like halogens. Therefore, position assigned to hydrogen in the periodic table is considered anomalous. Elements arranged in the modern periodic table show periodicity of properties including atomic size, valency, metallic and non-metallic characters. Here we shall see how various properties of elements vary across the period and down the group. Let's take the first property, which is valency. As you know, the valency of an element is a measure of its combining capacity and can be defined as the number of electrons that must be lost or gained by an atom to obtain a stable electron configuration. In a period, the valency of the elements increases from 1 to 4 and then decreases from 4 to 0 from left to the right, whereas in a group, the valency is the same for all the elements of the group. Now coming to the second property, which is atomic size. The term atomic size refers to the radius of an atom. The atomic size may be visualized as the distance between the center of the nucleus and the outermost shell of an isolated atom. You will see that the atomic radius decreases in moving from left to right along a period. This is due to an increase in nuclear charge which tends to pull the electrons closer to the nucleus and reduces the size of the atom, whereas atomic size increases down the group. This is because new shells are being added as we go down the group. This increases the distance between the outermost electrons and the nucleus so that the atomic size increases in spite of the increase in nuclear charge. Moving on to the third property of elements, which is its metallic or non-metallic character. As we can see, the metals like sodium and magnesium are towards the left hand side of the periodic table, while the non-metals like sulfur and chlorine are found on the right hand side. In the middle, we have silicon, which is classified as metalloid because it exhibits properties of both metals and non-metals. In the periodic table, a zigzag line separates metals from non-metals. The borderline elements such as boron, silicon, germanium, arsenic, antimony, tellurium and polonium are intermediate in properties and are called as the metalloids. Metals tend to lose electrons while forming bonds, that is, they are said to be electropositive in nature. As the effective nuclear charge acting on the valence shell electrons increases across a period, the tendency to lose electrons will decrease. Down the group, the effective nuclear charge experienced by valence electrons is decreasing because the outermost electrons are farther away from the nucleus. Therefore, these can be lost easily. Hence, metallic character decreases across a period and increases down the group. So, what about non-metals? Non-metals, on the other hand, are electronegative. They tend to form bonds by gaining electrons. Now, let's summarize the section. Mendeleev's periodic law was modified and atomic number was adopted as the basis of the modern periodic table. And the modern periodic law can be stated as: properties of elements are a periodic function of their atomic number. The modern periodic table has 18 vertical columns known as groups and 7 horizontal rows known as periods. In a period, the valency of the elements increases from 1 to 4 and then decreases along the period, whereas in a group, the valency is the same for all the elements of the group. Atomic radius decreases in moving from left to right along a period, whereas it increases on going down the group. What about metallic character? Metallic character decreases along a period and increases down the group. And so non-metallic character is going to be just the opposite. That is, it increases across the period and decreases down the group.